Hi, Algebra 1 students. These notes are on arithmetic and geometric sequences, which is also lesson 3 in your workbook. So we're going to be working on lesson 3 the next time you have class. And this is to kind of preview lesson 3 and also to wrap up what we were doing in both lessons 1 and 2. So arithmetic and geometric might be new words to you, but basically they kind of go hand in hand with two words you should be familiar with, which are linear and exponential. So an arithmetic sequence we can think of as being linear. It is linear. And geometric is exponential. So in arithmetic sequences, the key way of telling if it's an arithmetic sequence is you'll see repeated addition. To get to your next term. So you'll always add to the previous term to get to your next term. Okay? So if we look at, and when I say addition, we also mean subtraction, right? It doesn't. We could think about subtraction as just being addition of a negative number. So we're going to look at a couple of examples. So first of all, we're given a recursive formula. A of n plus 1 is equal to a of n minus 3, and a of 1 is equal to 5 for n is greater than or equal to 1. Now that might sound like a lot of nonsense or doesn't quite make sense, but if I kind of can decipher it for you, this a of n plus 1 is basically saying that the way you get to the next term in the sequence, the next term will equal the previous term, a of n, because a of n plus 1 is just one term after a of n, right? The plus 1 is going to the next one in the sequence. So the next term is equal to the previous term minus 3, and it also tells us what the first term in our sequence is. It says a of 1 is 5, right? So it's telling us our first number is 5. So when it comes down here where it says find the first 5 numbers, well, the first one is 5. And then to get to my next one, I'm subtracting 3. So 5 minus 3, 2. And then my next one, I'm going to subtract 3 again. I'm going to get negative 1. Then subtract 3 again. I get negative 4. And again, I get negative 7. And now I've generated the first 5 numbers in my sequence. Now, we can also kind of set up this sequence in a table. Think about the nth and the value of n, and I'm actually going to leave a spot for the 0th value of n, even though we don't really have it. Doesn't really make sense, but we are going to think about it for writing the explicit formula. So the idea here would be that the first number in our sequence is 5, so I'm putting that with 1. The second is 2. The third is negative 1. The fourth, negative 4. The fifth, negative 7. And we know that our rule here was subtracting 3 every time, right? So I'm going to kind of make a connection for us now to something we think about a lot with linear functions, which is the formula y equals mx plus b, because that's going to be our model for thinking about writing an explicit formula. And the only difference is instead of y, we're going to be using this a of n, which is function notation. And we're going to say instead of x, then we'd have an n, right? So in terms of our explicit formula, I know that the slope or the rate of change is going to be that repeated addition or repeated multiplication. So as soon as I see the minus 3, I know that's telling me I'm going to get a of n equals, definitely going to have a negative 3n. Now, I don't know what my b value is. B is the initial value. It's when n is 0, right? So I can come over here to my table and think about how do I get the number that theoretically came before 5? Well, I could go backwards, and now I could add 3 instead of subtract to go backwards in my pattern, and I would get an 8 right there. So that's telling me that I should have, for my y-intercept or my b value, an 8. So I get the formula a of n equals negative 3n plus 8. The other way of expressing this formula is to think about the first term in the sequence, and you still are going to use the same slope, but you'll do a of n equals negative 3 n minus 1 plus 5. So the idea there is I'm still using my same slope, but instead of putting my initial value in for b, I'm putting the value of the first term, 5, right there. But to kind of balance it out, then I make, where I have the n, I have n minus 1, right in here inside the parentheses. So what that does is if I plug in 1 for n, I get 1 minus 1 in those parentheses, which is 0. And the value of my function is just exactly 5, which is what I see when n is 1, the sequence is 5. That's the number in the sequence. Okay, so if that makes more sense to you and feels easier, you could use that, or you could stick with the y equals mx plus b. Now we can also graph the sequence on the coordinate plane by plotting points, because we have a point like 1, 5 is an ordered pair, and I can plot a point where I go over 1 and up 5. It's hard for me to accurately draw a dot on my coordinate plane, but you guys get the idea. That's almost at 1, 5. And then I would get 2, 2. That looks like about 2, 2. 3, negative 1. 4, negative 4. And 5, negative 7. Okay, and you can see that they are all points that would fall on the line, right? Negative 3n plus 1. Now, or sorry, negative 3n plus 8. Now, I'm not actually going to connect those dots, because in this scenario, when we're talking about a sequence, I only have these specific numbers in my pattern. So I'm not actually going to connect the dots to make a continuous line, because they don't have continuous solutions here. Okay, so if you take a look at example 2 on your note sheet, I'm going to make example 2 is going to be a U-try problem. So this is going to be a U-try. So it's similar to example 1. So do the best that you can, and we'll go over it in class. Okay, and then you can press play on the video again once you finish. All right, so in part 2 of your notes, we're going to be looking at geometric sequences. And the idea here is that these are tied to exponential functions. So we're going to see repeated multiplication here. Okay, so the idea is if we're given a sequence like the one below, 1, 3, 9, 27, the idea would be to start thinking about, like, is there a number you can multiply 1 by to get 3? Well, 1 times 3 is 3, and then 3 times 3 would give you 9, and 9 times 3 would give you 27. So we can see we have this repeated multiplication. Okay. Now, I think that writing the recursive formula is actually a little bit easier than writing the explicit formula. But let's start with the recursive. So the recursive formula here would be, okay, we're going to always start with the next term in the sequence. So we say the a of n plus 1 term in the sequence will equal the previous term, a of n. And then what are we doing? We're multiplying it by 3. Now we need to set the other parameters, right? So we need to say, and the first number in the sequence, a of 1, is, in this case, 1. Right, that's that 1 right there. And we also then we say that we're going to count up from 1. So we say n is greater than or equal to 1. So we're not going to go backwards in our sequence. And we could put this in a table of values because it might help us to get to our explicit formula. Okay, so here's our table of values. And then I can think about writing each of the numbers in my sequence as a power of 3. And I know it's going to be 3 because that's my repeated multiplication that I notice. So I'm going to start with the one that's most easy to see, which is the number 3 itself. So I know 3 is 3 to the first. And then if I kind of can keep going to the right, it's easy to think that then if I then get from 3 to 9, I multiply by 3, right? So this has to be 3 to the second, and then I multiply that by 3. So that's 3 to the third, right? And then I can also go back to my 1 and realize, oh yeah, that is 3 to the 0, because anything to the 0 power is 1. And now the key is to then make the connection between the value of n and the exponent. So like when n is 1, the exponent is 0. When n is 2, the exponent is 1. When n is 3, the exponent is 2. So we can kind of see that the exponent is always 1 less than the value of n. Which means that for our explicit formula, I'm going to write a of n equals 3 as my base number to the n minus 1. So it's n minus 1 because I know that when I plug in 1 here, I'm going to get 1 minus 1. That's going to be 0, and I get my 3 to the 0, which is my first term. Okay, so if that still feels a little uncomfortable, don't stress. We are going to keep practicing this in class.